coming. Thank you for joining. We will start soon. Hello, Bor and Francisco.
Yeah, hi. Can you hear me?
Yes, I can hear.
Hi, Thiago.
Hello. Hello, Vinit.
Hello, how are you?
Yeah, all good. Thank you. So this is our first event, online event of Melbourne Cloud Native. I hope everybody will enjoy. And this will meant to be a every other week event. So I hope this is a nice event that everybody can enjoy. And we will have a discussion, so everybody is welcome to leave questions and also answer questions. I have one question in the beginning here. Who have joined any other Cloud Native community group before? Anyone?
One.
Okay, yeah, no worries. Welcome, Kota. Yugash Vara. Yeah, welcome. I will still wait more 3 minutes to having people join, and then we will start. Okay. It's a bit quiet, so if you have any thing to talk about, who knows about the topic that we are talking today?
So it's going to be on eBPF, yes?
Yes, exactly. Today will be a talk on eBPF. It's more an introduction to eBPF. We are not going so deep in the code itself, but I want to show how it is revolutionary and what we can achieve with the eBPF.
Nice, Thiago. So actually, 4 of us, we are joining from Rakuten Mobile, and we are from the next generation and advanced research department. So our team members, they have hands-on experience and they worked on a eBPF project for transport. So
cool.
we'll be definitely more than happy to have more discussion with you, probably.
Yeah,
So it's possible for you,
amazing.
yeah, on separate call also.
Okay, cool. Yeah, that will be really appreciated, and thank you for joining. It's always good to have people with a hands-on experience and also to contribute to our discussions. Thank you so much. I hope I can add something, or at least my point of view on this technology. That'll be interesting. Thank you.
Thank you to you.
Thank you. Hey, Makara, welcome.
Hi, Thiago. Hi, everybody.
Hello.
Hello.
Hey, Robbie, welcome.
Hello. Hey, buddy. How you doing?
Oh, good. Hey, hello. I can see your faces now. Great.
I'm trying to get my camera working. It does
Yeah.
now.
Amazing. Good to see you, Makara. Thank you for
To see you
joining.
too.
Okay, so I believe it's time to start. I will start sharing my screen. I hope everything is okay. Everybody can see my screen.
Yes.
Let me just bring it.
Yes, we can.
Yep.
Just introduce a little bit of myself. My name is Thiago Shimada Ramos. I am a Cuba astronaut and the chapter organizer for the Melbourne Cloud Native community. Thank you for joining this session today. I promise that it will be really quickly. And today we will be talking about this thing that it is revolutionizing the cloud native world. So it's a technology that will change how we manage, observe, secure, and optimize complex systems, and it is called eBPF. So to appreciate what is the impact of the eBPF, it's better for us to step back and take a look on the basics. So how operational systems really works is we have a user space and the kernel space, and they are separate. And the kernel space is where the core of the operational system, which control the files, the memory, the network, and everything else is controlled in that space kernel. And usually what we interact it is on the application layer, or it is the user space, like this Zoom call or what everything that you usually use. So this is the basic of the architecture. To change this kernel, you can make like modules, or you can also compile a new kernel, but it could be a little complex because it is close to machine language. And also if you do something that breaks or do not integrate well with the kernel, it can make the entire system to crash. So then you have a no functional operational system. So that's why traditional kernel changes require kind of a long run. So kind of waits to have a new compiled kernel, and you have to restart the systems, and maybe is a bit risky. So that's why eBPF is revolutionary, because with eBPF, this is a eBPF program. You can run a program inside the kernel on the same privilege of the kernel systems, but this program, it is safe, and it is only executed when have some event. I will explain a little bit more what it is this event. And this happens without making any change in the code of the kernel. This is why eBPF is kind of revolutionary. Looks simple. It's just okay. It's just another program running. What is the cool part on that? But this is really powerful. So just a little overview. This is from the eBPF Foundation. We have some use cases already for eBPF related to network security, observability, and tracing. And we have some projects that we can use already, and it is already changing how we interact with the internet, as you know. Maybe you have heard about Cilium or Falco, Catran, maybe I'm not sure if you have heard about these projects before.
Yeah.
And cool. Yeah. Yeah, Cilium is a really powerful network based on eBPF. Falco uses eBPF for security. Catran is related to load balance. And these projects are building in a language that could be C, or you can use the software development kits in different languages like C++, Rust, even Python, to compile code for eBPF. And this eBPF is a code, it's a program that then it's go inside the kernel, passing through a verification, then we have maps, and then it runs. And then it has this applicability of the kernel. And this is just the beginning. This is really, the possibilities are really limitless for what the innovation that the eBPF gives to us. So I want to walk through these pillars of the eBPF. Let's start to, so how this eBPF program can be so powerful. Always starts with the eBPF program bytecode. After you write your code, you compile this to a bytecode, and this is load to, let me see if this works. Here you can see, oops. I'm passing it more than one. Let me go back one. Sorry, yeah. So you can see my mouse maybe.
Yeah, we can see it.
Cool. So yeah, it will be easier for run this. So we have this eBPF program that it is already by code, and you can load this to the kernel using this function. It's called BPF. And when it's loaded, so you have your program already wrote, and then it goes to the kernel. Why the kernel programs need to be verified? Because it is really, let's say, it's a restricted level. So you need to have a kind of verifications to pass to this level. And this time you have a verification that it verifies if the program will run safely. And also if you don't have any loops that will not end, and if it is also restricted in what access of memory it has. So if pass the verifier, then it will be compiled, because the code, if it is not compiled, it will not run close to the machine, or the machine level code. So this is where you can have the safety, the performance, the safety and the performance of the eBPF program, because it will run really close to the machine native language. So once it is loaded, it is still sitting in the kernel. It is not running in the CPU of the kernel, is not loaded in the CPU. It's sitting there waiting for events. But at the same time, when you compile this, it also will create the eBPF maps. And the eBPF maps is a way to interact, sending data between the kernel level, kernel space, and the user space. Is a key value stores kind of a database that both the kernel level can write and read, and the agents using this eBPF program that it is in the user layer can also write and read. So while the program is sitting there, it's not executing any code, okay? The next part is when something happens. This something is events capture. So usually when you use your apps, or when you use your apps, you execute something like print something on the I'm not sure how many of you have used Linux, but if you use a command like cat to print a text in the file system, in the terminal, it will make some system calls to print that in the terminal. Also, any execution will call something, you make this syscall. And this is where you can attach your eBPF programs. You can attach to specific kernel rooks, or such as the system calls, or you can attach these to the network events, and also to the trace points in the kernel. So events, even if in this diagram it's saying that it is from application, these events can be either network events or trace points as well. So when it's loaded, so when this event is triggered, then the program, it will be executed, the eBPF program. So the eBPF program capture this event through the rooks, and then it can process the data and store this data in the eBPF maps, that is the database. And this data can also be read and write back to the agent. And this is where kind of the magic happens, because if these agents decides that, okay, we are receiving this data because of these programs, they can dynamically rewrite the program in PBF. And because the eBPF program can be loaded to the kernel without needing to reboot the system or anything, it's zero code deployment. It can be, again, deployed inside the kernel, a new eBPF program. So this eBPF program can be optimized during, even if it is, I'd say, it can be optimized in the real time. And then after doing this transformation or the program itself, the program can do a simple thing that it is just capturing and save the data, or just send back information, or the program can decide to filter out some data in the package, or decides to block the execution of that. And then it sends the eBPF output, and then it go back to the kernel subsystem that it was part of that event, either the network or the storage system. Anything is possible here. Almost anything, okay? It's not everything. But this is the basic flow of eBPF program. And this is really interesting because this program can be compiled and run in any kernel that it is compatible with the eBPF. eBPF is available since, I believe, kernel 5.12. Not totally sure, but is kind of recently kernels that is available in the new eBPF. The BPF program it's there for a while, but this new system called eBPF that you can load the eBPF program is quite recently. But all these new kernels that is available for eBPF allow you to run the same program. So you don't need to create a different program for a different kernel if this kernel already have enabled eBPF. This is a really powerful thing for eBPF. Now that we understand how eBPF works, we can take a look on some other tools that make it really powerful. And I would like to mention this figure that is called Brendan Gregg. He's Australian, the performance expert who has worked in eBPF for a long time. And in his book, BPF Performance Tools, Linux Systems Application Observability, he go through a range of 150 programs, and a lot of these programs he created to write this book. And in this picture here, we can see the other subsystems that you can attach eBPF programs using rooks. So you have the network stack here and the storage as well and the memory. So every subsystem inside the kernel you can attach some rooks, and especially for performance is really interesting. Brendan Gregg is also the creator of the FlameNet graph, that it is a tool that become the standard for proofing and performance analysis. Cool. And following Brendan Gregg groundbreaking contributions, we can also talk about Cilium. Cilium is another technology that has pioneering in the eBPF space. And in here we can see how they revolutionize the network inside the Kubernetes. So on the left side here is the standard container network. And usually the network has these IP tables and the routers. And this is because this is a side node, right? And inside the pod, you have the same kind of system that it is the virtual network. But using eBPF, you can come over this overhead and make it much more directly, reducing the latency and also improving the performance. So on the right side, you have the eBPF way of doing the network. So it gets the information as soon as possible when it comes from the pod, and it bypasses the entire IP tables stack, making it much more efficient. And also eliminating the complexity and the limitations of IP tables for scalability. Because inside Kubernetes, when you have so many nodes and pods, IP tables do not perform really well. Another real-world adoptions that I can mention is Meta. So the project at Katran, as I told before, is usually for load balance inside Facebook, and it's being used to control and deliver all the cat videos that you have in your feed. We can talk about the DDoS mitigation by Cloudflare. DDoS is the denial of servers, and they use eBPF to control this inside the network stack as well, using hooks and network events. Netflix has an application inside their systems that it is for fixing noise neighborhood issues. Noise neighborhood is when you have a multi-tenants inside your cluster or server, and they can control really close granular what it is happening in that space. And one thing that it is quite recently and is still kind of in beta, not in production, is the Microsoft eBPF, eBPF for Microsoft. So eBPF is not just for Linux anymore. Microsoft is adding support and bringing this to the Windows servers. So from speed to security, eBPF has become the hide engine for the internet, shaping the services that we rely every day, and it's just getting started. So we have some future trends here, and I believe I will mention Dr. David Soldani for the integration with the 5G for monitoring protocols with low latency networks. And we have some applications with AI, and I have mentioned some figures, researches as well. The one thing that I would like to point out is this standardization with the publication of the BPF instruction set architecture on last October last year. And why this publication is so important is because where this was published is the same international technology workforce for the internet, and they are who kind of standardizes the TCP/IP protocols back in the 19s. And when they standardize something like this, that it is the instruction set for eBPF, means that the whole industry now can rely in something that it is mature, and they can start building more for this technology, which will allow more things, especially like edge computing and other vendors to gain this, to harness the power of eBPF. So this then highlights how eBPF is really a transformative force. So Rakuten mentioned, so Rakuten Symphony teams led by the Soldani is pioneering in the 6G architectures powered by eBPF. This architecture seamlessly integrated space, air, and ground networks to optimize communications pathway through thousands of devices, reducing latency across multi-layer networks and enhancing real-time security observability. Because Linux is using billions of devices, eBPF can be deployed in billions of devices as well. So this ensures data flow between space-based, ground-based systems, which is crucial for the 6G success. So how are you feeling? The power of a BPF? If you want to start, you can just go right now and go to eBPF.io and take your first step to learn what is a BPF. You can start there. That is your home base. You can have all the documentations, the community, everything. You can go there tonight. Second, you can put your hands on, get hands-on on a BPF. I did this lab last week, and it's really interesting. You can really create and see a BPF running. You can do like your hello world program in a BPF. You're not really doing much more than it, but this is really good to grasp how it works. So you can go and check more this week. And also I invite you to check this World of Cilium. As you can see in this map here, they have kind of a pathway for different professionals, from network engineers to cloud architects. And you can explore more how Cilium and the other projects that they have created by Sovalent. It's leveling up a BPF. So, and after finishing this, you also can get your free badges. This is some references that I use for this presentation. I really recommend this official documentary. If you like a tech documentary, it's really interesting. And I will share this presentation with you. So think about it. The BPF is ready, and maybe just maybe you are going to use it to solve problems that we haven't dreamed yet. So go explore. Thank you.
Thanks, Thiago.
Thanks, Thiago.
Thank you, Thiago.
Thank
So-
you.
Thank
So
you.
just one quick question, because our team actually we worked on different parts of the eBPF, as you were just discussing on network part, the transport, the observability, and also the security.
Yes.
So especially however eBPF has is providing a really high performance agentless observability, but it's also it's also introducing some potential security risk that we're aware of that. Like, for example, with the privilege escalation, even you were discussing about the eBPF map. So as it's a shared kernel memory, that if the attacker is going to occupy that, or will definitely face with the denial of service in terms of the resources. But I'm curious to know that have you worked in any a security context of eBPF? Do you have any hands-on experience? Because we are definitely quite interested to have a separate call also. Mainly related to, because we already have the product in production. Okay. But so, or any your team member that we can just discuss about some issues definitely related to the some of our concerns related to the security and the rest.
Yes. I can introduce you to Robert. He's in the call here, and
Okay.
I'm pretty
Nice.
sure that
Hi, Rob.
yeah, Robert has more inputs on that. He gave a presentation last week on modeling, threat modeling using eBPF, and he
Excellent.
works for control plan. So
Mhm.
Robert, if you wanted to get in touch with the board to have a call later on, I believe it will be really
Definitely.
opportune for you.
Yeah, thank you so much. Hi, Rob. So nice to meet you. We'll
Hi
definitely.
there.
Okay, so we should connect via LinkedIn, or you're gonna share?
Yeah, I was just looking up your profile then, so I'll send you a connection request. And
Okay, excellent, Rob. Thank you. And my team members, all of them, they are here. Majority of them that they are working, Francesco Monaco, that he's expert in eBPF, Daniel Yogesh, and so we're all from Rakuten. Anyway, yeah.
Yeah, perfect. No, I'd love to talk about it.
Thank you. It was a nice session. Thanks, guys.
Oh, thank you. Yeah, I hope this kind of overview again of what is possible with the BPF has been eye-opening for everyone.
Mm-hmm.
Good, great. So this month the focus will be eBPF still. We have another session in 2 weeks that we will talk about Kepler, and I hope this session has been insightful. I know that it is quite a lot of information in just 20 minutes or 30 minutes, but doing in a short version like this make it easier for everyone to join and grasp a little bit of what's going on in the cloud native world. Okay, and it looks really promising to have this connection as well possible during these events. So I really appreciate everybody that have joined. Thank you.
Thiago, I'm kind of interested just from the people who are here. How many people are in or based around Melbourne, and how many people are from wider afield? Can you virtually raise your hand if you're from Melbourne?
I am from Melbourne.
I'm from Melbourne.
And I'm from Sydney.
Okay.
I'm with David. Yeah. Another
Yeah.
colleague of mine, he will definitely join in the next call. He will be also from Sydney.
So this virtual format that we're doing at the moment for Cloud Native Melbourne seems to have captured a nice wide audience of people. So some from Melbourne and some from wider afield. That's really nice.
That's good. It's well, it's Melbourne time, but Sydney time is the same. And because it's online, it's open to anyone that is available to join during this time. Okay.
And our team, they are connecting from Tokyo.
Oh, cool.
Yeah.
It's really good to see people all around the world join Robert and I also are part of the APEC hashtag for Linux Foundation. So we have also meetings related to security every 2 weeks. And that's where Robert has make a presentation on threat modeling.
Oh, nice. Yeah, we're definitely with that one as well.
Cool. Cool. Yeah. If you want to, I don't know if you're already connected on LinkedIn, please, if you want to share your profile in the chat with everyone, you can connect. And we are almost finishing our session. Any other topic that you want to discuss or have covered in these meetings? I have a plan already ahead for 4 sessions, but my creativity is not that huge to program ahead, and also I want to have more input from all the attendees. So if you have any topic, please share with me. Don't need to be right now, could be later. We will be trying to make this session friendly and also relevant to all of you. Okay, so I believe that's it. Thank you so much for joining today. I hope to add everyone connect again, and see you in 2 weeks.
Thank
Thanks,
you.
Thiago.
See you guys. Thanks.
Thank
Bye.
you.
Thank you.
Bye bye.
Thank you.
Bye.
Thanks, everyone.
Thank you.
Thank you.